Hi dear viewers, I am Devdas. I like to explain atomic absorption and emission spectra in this video. When atoms are excited by thermal energy or electrical energy, they are going to absorb the energy as well as they are going to emit the energy. You can study either the amount of energy absorbed by the atomic population, or we can measure the intensity of emitted energy after getting excited. So in this video, how atomic spectra, both absorption and emission spectra obtained, what is the theory behind, and what is atomic absorption and atomic emission spectroscopy. Joseph van Fraunhofer, 1823, is a scientist who studied solar spectrum. He observed 8 dark lines, namely A to H, in the solar spectrum. Certain elements in the outer core of the sun absorb radiation of specific wavelengths characteristic of the element. Absorption by sodium atoms gives to an intense line at 589.3 nanometer in solar spectrum. So the solar spectrum is nothing but the light from the sun is allowed to pass through a prism. Now the prism disperses the sunlight into VIBGYOR. So when it is obtained, when it is received on a photographic film, the sunlight is dispersed as VIBGYOR, which could be seen as 7 wonderful colors. But when Fraunhofer done this experiment, he observed 8 dark lines, which are black colors, black lines, and he labeled them as A, B, C, D, E, F, G, H, like this. What these dark lines stands for? What happened for obtaining the colorful VIBGYOR like this? So this is due to the excitation of the electrons in atomic orbitals to higher energy states that may be induced by thermal energy or electromagnetic radiation. If the energy of the radiation exactly matches to the difference between the upper and lower energy states. So what happened? The outer core of the sun is filled with the sodium vapor. Certain population of sodium atoms going to absorb some radiant energy or thermal energy, sunlight frequencies that matches to the difference between their upper and lower energy states. So this is the sodium partial energy diagram. So that sodium, the outer shell consists of 3s1 electron and the next is 3p, 4s, 3d and 4p. So the outer core sodium vapor receives the energy, and this energy will be utilized for excitation process. So the excitations may be depicted in the picture from 3s to 3p and 3s to 4p, 3p to 3d, because 3s1 electron is the outermost electron in the atomic orbital of sodium atom, so which jumps to its higher energy by taking the solar energy in the sunlight. Thereby there might be some missing lines. So like this, depending on the atomic orbitals, outer core orbitals, depending on the number of electrons filled in, depending on the type of the atom involved, the electronic transitions may be propagated by receiving the energy. So these energy levels are characteristic for a particular atom. This is the case of sodium. During the absorption of thermal energy or electromagnetic radiation, which shows some electronic transitions characteristically 3s to 3p, 3s to 4p and 3p to 3d. So atomic absorption spectrophotometry is a technique for the quantitative determination of elements, metalloids, based on the measurement of absorption of monochromatic light by ground state atoms. So in the atomic absorption spectrophotometry, there an instrument called atomic absorption spectrometer, which measures the extent of the energy absorbed by ground state atoms. Kirchhoff and Bunsen, in the middle of 19th century, was studied about the different flames, different colors of the flames.